Hi, I'm Dilena Mendes and I'm here today to discuss about Unit 2 mid-unit assignment. Let's look at question 1. The regular motion of the Earth about the Sun causes the daily change in the high temperature at any location on Earth. The chart and graph shows the average daily high temperature in degrees Celsius for each month in Yellowknife NWT compiled for several years. Determine the trigonometric equation that models this information. Let y be the temperature in degrees Celsius and x be the numerical value of the month. The general equation is fx a cos open brackets k brackets into x minus d plus c. If we show it in a graph, we can see the graph is a cosine graph. Amplitude equals the maximum value minus minimum value divided by 2. So 21 minus 24 divided by 2 will be equal to 22.5. K is the period. Period equals 2 pi over K. Therefore, K equals 2 pi divided by period. The 2 pi divided by 12 equals to 2 pi over 6. Axis of the graph is maximum value plus minimum value divided by 2. So 21 plus minus 24 divided by 2, which equals to minus 1.5. When looking at the graph, we can observe it spans 12 months with the first coordination shortness occurring in January. So D equals 1, 1 unit to the right. D equals the phase shift. According to the equation, the trigonometric equation is fx equals minus 22.5 cos brackets pi divided by 6 brackets x minus 1 close brackets minus pi. So let's look at the second question. A Ferris wheel has a diameter of 10 meters and takes 24 seconds to make one revolution. The lowest point of the wheel is 1 meter above the ground. Sketch the graph to show how a rider's height above the ground varies with the time as the Ferris wheel makes a rotation. Assume the person start the ride is at the lowest point of the wheel. B. The trigonometric equation that describes the graph. C. Check the accuracy of the equation by using t equals 12 seconds. Explain why this provides a check of the accuracy of the equation. What are two more values that would provide a good check? So this is the Ferris wheel and it's 1 meter above the ground, and the midpoint of the Ferris wheel will be 6 meters above the ground, and the full height of the Ferris wheel, which means from the ground, which means from the bottom part, it will be 11 meters altogether. This is the diagram. This is the answer for part A. So part B, the graph is a cosine graph, so we can apply the equation f equals a cos open brackets k open brackets x minus d close brackets plus c. Amplitude A is maximum height minus minimum height divided by 2. So 11 minus 1 divided by 2 equals 10 divided by 2. So A equals 5 meters. K is the period. So K equals to 5 divided by period. If the period is 24 seconds, K will be 2 pi divided by 24, which is 5 divided by 12. C is the maximum height plus the minimum height divided by 2. So 11 plus 1 divided by 2. So 11 plus 1 is 12. 12 divided by 2 will be 6. When looking at the graph, the minimum of the graph reaches to y equals 0. Therefore, d equals to 0. The trigonometric equation is y equals minus 5 cos 12 over 5 divided by 12, open brackets, x, close brackets, plus 5, plus 6. Time t equals x minus axis. There is a vertical reflection, so we must apply minus 5. When t equals 12, y equals to minus 5 cos, open brackets, 5 over 12 into t, close brackets, plus 6. y equals minus 5 cos 5 over 12 into 12 plus 6 minus 5 cos x plus 6, which equals to minus 5 into minus 1 plus 6, which is 11. The height will be 11 meters at t equals 12, as the graph shows. There are two more points that might be utilized at t equals 24 and t equals 0 to verify the graph's accuracy. When t equals 24, y equals to minus 5 cos 5 over 12 in t plus 6. So 24 is t, therefore the equation will be minus 5 cos open brackets 5 over 12 into 24 plus 6, which gives minus 5 cos into 2 5 plus 6, which is minus 5 into 1 plus 6. The final answer will be 1 meter. When the height will be 1 meter at t equals 0, as the graph shows. Let's look at the third question. The height of the tide in the Bay of Fundy relative to a pier varies from a low of 4.5 meters at 0.28 to a height of 17.3 at 8:21, measured with 24-hour clock. Assume that the height h of the tide can be modeled as a cosine function of the time of the day, and then determined from the equation in the form h equals a cos k brackets t minus d brackets o plus c. When h is the height of the tide at the pier in meters and the t is the time of the day in hours, determine the height of the tide relative to the pier at 11:30. Give your answer to the nearest 1 meter. D. A boat needs a depth of at least 12 meters to the dock at the pier. Use a graphical approach to determine the boat is able to dock and when it must leave. A. H into T equals A cos brackets K brackets T minus D brackets O plus C. The amplitude equals to the maximum height minus minimum height divided by 2. So 17.3 minus 4.5 divided by 2 will be 12.8 over 2, which is equal to 6.4. The time difference from 8:21 to 2:08 low tide to high tide is 6 hours 13 minutes. 6 hours plus 13 divided by 60 will be 21. Half a period time taken to reach from low to high tide. So half of a period equals to 6.21 hours. Therefore, a period is 6.21 into 2, which will be 12.42 hours. K equals to 5 divided by 6.21. C is the maximum height plus minimum height divided by 2. Therefore, 17.3 plus 4.5 divided by 2 will give 21.8 over 2, which is 10.9. We must consider the maximum height in order to determine D, and the tide reaches its minimum height at 2.05 minutes. Therefore, D equals 2 hours 8 minutes, and 2 hours 8 minutes divided by 60 will be 2.13 hours. Also, there is a vertical reflection. Therefore, A equals minus 6.4. So the trigonometric equation is h into t equals minus 6.4 cos brackets pi over 5.2 t minus 2.31 brackets of plus 10.9. 11 hours 30 minutes. 11 hours plus 30 divided by 60 equals 11.5 hours. H into t minus 6.4 cos pi over 6.4 t minus 2.13 brackets of plus 10.9 minus 6 cos into 5 6 divided by 6.29 brackets 11.5 minus 2.13 brackets of plus 10 minus 9. 6.4 cos 5 over 6.21 into 9.39 brackets are out plus 10.9 will be 6 minus 6.4 cos brackets 5 into 1.51 brackets of plus 10.9 minus 6.4 into 0.027 plus 10 will be 0.173 into 10 to the power of 9. It will result in an answer 10.73, which is roughly equals to 10.7. This is the part B, which is the graph given. The board is able to dock after 5 and leave after 12. Thank you for listening to my discussion.